Good afternoon. I would like to tell you about the results and plans of two perspective programs, NWO perspective programs. I got the opportunity to be the coordinator. In this slide, you see that in the Netherlands, though we have a lot of water, we are a water country, known for it, we are also under the pressure of a shortage of fresh water. And that is not only for industry, it is for drinking water, it is for agriculture, and it is also for our natural systems. And what we learned the last years especially, that we are suffering from seasonal droughts. And that means that we need to change something. And the Netherlands is known for water management because of safety. We are champions in getting rid of water if there is too much water. But we still have to learn the other thing, to preserve water, to retain water in our system, to be able to overcome droughts. And that's where the two perspective programs were about. The first one started already in 2015, was called Water and Access, and was oriented on industrial water provision. And you see here an industrial plant close to the shore, close to the sea, where the environment is completely dominated by salt water. So there is a problem in the freshwater provision of these industries, and they consume or need a lot of water for their production. So the slogan of the program we have, after discussing with the industries what do we need to do, is salt where possible and fresh when needed. Or in Dutch, zout als het kan en zoet als het moet. What did we do? So this was a program of 17 PhDs and postdocs. So we're doing research, and I have, of course, limited time to explain all the details. But what did we do? We studied the fresh and brackish water resources in the subsurface by using advanced modeling and radar technologies to describe the interface between fresh and brackish water in the subsurface. What we also did is we developed advanced modeling techniques to design networks. If we want to use brackish water or maybe wastewater as a resource, we have to connect the supply of these alternative water resources to the users of that water, and that infrastructure is not there. So we need to develop the connections between demand and supply, and that is what we did also in the project. Another thing we did is we developed new technologies, treatment technologies, to make water fit for purpose. Using advanced oxidation processes, membrane technologies, and also biological processes. And one of the things we found is that many biological treatment systems are based on granules, bacteria that coagulate, stick together in reactors, but they fall apart if there is too much salt in the system. Our wastewater technologies are designed for freshwater systems. And what we found in this technology that we can create these biogranules even in water concentrations 3 times seawater salt concentration. So this is really a new advancement and also leading to new microbial and other insights that are now a base for more fundamental research we are currently doing. What we also learned that water fit for purpose cannot be accomplished by one technology. So we developed technologies, membrane technologies, advanced physical chemical technologies, and nature-based type of technologies, wetlands, and put them in a technology train, and together we could create the good water quality needed for water reuse. And what we also did, we started to collaborate internationally with Vietnam, Chile, and the Middle East. So this was the base, Water Nexus was the base of a new project, but before finishing Water Nexus, we created a very nice end report. We have that with us. Thomas Wagner, PhD in Water Nexus, now postdoc in AquaConnect, the next program. We have a number of these copies with us, so if you are interested, come to us. The next project is AquaConnect. So we didn't stay only with industry, we expanded to the drinking water sector, to the nature conservation sector, and to the agricultural sectors. And in that program, we started to define or create so-called smart water grids. That idea came from the network modeling we did already in Water Nexus. And the idea is that we use alternative water resources, so wastewater, and treat it so that it becomes reusable, brackish water, which is in the subsurface, and also rainwater that can be stored maybe also in the subsurface as a source for water reuse in the local environment. In addition to that, we need to develop another set of technologies. So we are now focusing in this program on so-called treatment technologies based on membranes and electricity. So electromembrane technologies. For the specialists, we call them elektrodialysis. And these technologies are needed to remove specific components out of the water stream to make them reusable. In addition, we have so-called nanofiltration technologies, and the combination of that is then helping us to make that water reusable. In addition to this, we develop models. Again, advanced models to make these smart water grids possible. What we did in Water Nexus was completely technology-oriented, with universities that were very good at that, and industrial partners that were involved in that program. But what we learned is that if you want to make water reusable, you cannot do this only with technology. You need to adapt the legislation, because there are many laws that are blocking circular water approaches, but also we need to do something about perception of users. For instance, if you think about wastewater and then treat it and make it reusable, you can imagine that industrial but also public end users will have some perception issues with reusing that water. And how to overcome these issues is part of the research. Now, we don't work alone. We work with 7 universities and 4 applied institutes. You can see that in this slide. We work with 17 companies and with 18 governmental organizations. So this is really a big group of people working together. These stakeholders, they are connected to the case studies in the Netherlands we work with. So we have 4 regions in the Netherlands where we want to apply our ideas to first ideas of the smart water grids. So we have 3 regions in the western part of the Netherlands, in Zeeuws-Vlaanderen, Zuid-Holland and North Holland. And these regions are all dealing with problems related to salt water. Because of climate change, we have saltwater intrusion coming into the system, and the freshwater supply is more or less threatened by the presence of a lot of salt water. And we have also case study areas in the eastern part of the Netherlands where we are dealing with the problem of the depleting groundwater table because of over-extraction of the water and the occurrence of more and more droughts which we have experienced last decades. In addition to this, I already mentioned that we have some international collaboration via all kind of twinning programs. We connected to the AquaConnect program in Chile, Vietnam, Bangladesh, and also in the Middle East. And our vision is, in the end, that we will be able, in the western part of the Netherlands, create a water storage for horticulture and industry, by making that sector drought resistance. And the same we want to do in the east part of the Netherlands. You see a wastewater treatment plant there. That water is now fed into the river and lost to the sea. And in the near future, through AquaConnect, we want to preserve that water and bring it to nature, agriculture, and industry. And thank you very much for your attention.
Thank you.